Okay, here we are. This is 11.3 day number 1 on area of a triangle, 3 different ways. Let's talk about those. I'm going to give you the first one, which you should probably just totally get. Right? Let's say we have a 3, 4, 5. Right? Area of that triangle, we'd take 1/2 base times height. So I'd take 1/2 base, which would be 3 or 4, times height, which would be 3 or 4. It looks like the area would be 1/2 of 12, which would be 6. Okay, pretty common, 1/2 base times height. That only helps if you know the height, right? What if I don't know the height? Well, what I can do, we'll say I know this. Oh, that looks familiar, alpha. Hello, friend. That's 10, and let's say this is, I don't know, 12. Well, if I don't know the height of the triangle, if I do know an angle in between those two sides, I can find the area of that triangle. I'm going to use the formula that we know, 1/2 base times height. There's a way for me to solve for height. Remember that? What did we do to see if there's an ambiguous case? We found the height. The height is 10 times the sine of 42. Someone last hour said, where'd you get that? Well, if I took the sine of 42, that would equal the height over 10. So then I just multiplied by both sides, right? So the height is 10 sine 42. So in essence, what I'm doing is I'm taking these two sides. Let's call them, I don't know. Let's call this one C, and let's call that one B. Right? In this case, B is going to act as side B, not the base. But I would have side B times side C times the sine of the angle in between. And so we can find the area of a triangle if we don't have the height by finding the height using the angle in between the sides. So this formula here is useful if we have an angle between two sides. So what did I need here? I only needed two sides here, right? Because it's a right triangle. That's too easy. One acted as the base, and one acted as the height, and then we divide by 2. Here, I need two sides with an angle in between. And there's actually a third formula, which we're going to talk about in a moment, where I can find the area of a triangle using this formula. And it's called Heron's formula, but we like to call it Hero's formula because this person was probably a hero to the folks back in the day. This is used to find the area of a triangle where all you know is 3 sides. You don't have an angle. So let's confirm it. What did we say, the 3, 4, 5? That's not even close to scale. Let's try that again. Let's put the 5 here. Oh, cool. Let's put the 5 here. Let's put the 4 here. We said the area of this was 6, right? Okay, so let me show you how this works. Here's how this works. S is equal to A plus B plus C divided by 2. Who came up with that? Well, some old person. I don't know who it was. Probably someone named Heron. But we'll call him the hero. Okay? So let's find S. S would equal 3 plus 4 plus 5 divided by 2. 3 plus 4 plus 5 divided by 2. Well, that'd be 12 divided by 2. So S would equal 6. Is that the area? No. That's just S. So to find the area, we take the square root of S, which is 6, and then S minus A, and then S minus B, and then S minus C. So our area here would be 6 times 3 times 2 times 1, which is the square root of what? Bam. The area is 6 units. I guess I could go generic and just go units, but it works. It's cool. This is useful. This formula, right? This is useful if we know all 3 sides. So in the scenario where we know all three sides, we can find the area. Say again. What's the most common mistake made when using Heron's formula? It has to do with this number right here. They forget to divide by 2, or they divide by what? 3, because they think, oh, I'm going to average the sides. No, it's divide by 2. So it's always 3 sides added up, divide by 2. That's how you find S. And then someone will do this. This is the second most common mistake made using Heron's formula. What are they going to think that is? The area. They're not going to use the actual formula, which it is, coincidentally, but it's not always, right? Okay. All right, so let's keep going. This slide basically was going through this formula right here. We were going to formulate this, AB sine of C. I don't like to attach letters to these. Like, I don't really like A and B and C, so I just use side angle between. Okay, I consider this side angle between. Is that text language for between? Okay. I would think that'd be like, by the way. No, that's a different one. BTW. I thought that was.
Which could be between.
Which could be between. That's totally messing with my head. BTWN is between. So BTW is like Batman, Tango, waffle. Batman, Tango, frozen waffle. BTFW. Now what am I? This is recording. Yeah, imagine how many hits this is going to get. People are going to like this. They're going to comment below. They're going to subscribe just because. Okay, so I like to think of these as just sides, right? So don't think of, like, because you might have a triangle that says XYZ. Well, which one do I call C? Well, it depends. Not the underwear, it just depends. Okay, is this working? Is this on? Yeah, it is. Okay, good. All right, so are you with me? Okay, cool. So let's do a Heron's formula. Find the area of that. Okay, let's do a Heron's formula. Area is, well, we got to figure out S. S equals 5 plus 7 plus 8 divided by what? 2. Don't divide by 3, children. That's 20 divided by 2. So S equals 10. So I've got 10. What comes next? 10 minus whichever one you want, as long as you don't repeat it. 10 minus 7. I typically go in ascending order, least to greatest. 10 minus 8. Let's find the area of said triangle. That'd be 10 times 5 times 3 times 2, which is the square root of 50, 150, 300. Does that look right? Okay, and if I reduce that, I'm just going to do this in my head. That's going to be 10 root 3. So I'm thinking 17 point something. Somebody confirm. 10 root 3. You could leave it like that. Or 17 point what? Somebody got it out there? 3.2. Units squared. If there's no units attached, I'm okay with you just making up units as long as they actually exist. Okay, I had some kid put like pigs squared. I'm like, no, centimeters, meters, inches, feet, whatever. Okay, cool. So there you go. We got Heron's formula here. Let's do a homework problem. How about that? All these problems will be find the area. Even though this problem right here doesn't say find the area, it's find the area. So let's do this one. How about that? Help me with the setup, and then you can execute. Which angle do we want to call C? Small one, this one over here. Let's call that C. So that'd be 31 degrees. Does it matter if I put the 43.17 here? No, I could put it here. Could I put it here? No, definitely not, right? That has to be C, but it could go either here or here. So I'll put it here. It seems like a number that belongs there. Okay, so if that's side A, then that makes this angle A. That makes this side C, which is 24.15. That makes this angle B, and that makes this side B. I need one of three things. I either need side, 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 side angle, side, or a side, side with a right angle involved. Am I going to have that third option? Not conveniently. Boy, I could probably find either of these two. Which one's going to be easier? I think this is going to be easier. Right? Because I'd have to find angle B before I'd find side B. You with me? So what I want you to identify, I want you to find this. I already have A and I already have C. So I want you to find angle B, and then we can use this right here. Okay? Work with a neighbor, find angle B. I'd say probably use law of sines. Okay, use law of sines to find angle B, and then we'll come together and we'll figure out what the area of this triangle is. Okay, so let's recap what we've got here. I'm gonna do something that I think might be kind of cool. Watch this. Watch this. I'm gonna make myself a pointer. Yeah, there we go. So I use the law of sines. Sine of 31 over the side across equals sine of A over 43.17. I cross multiply. I get that equals that. I divide by this 24.15 over here. So I get sine of A, this is an angle, over, it equals this. If I inverse sine the right side, what happens to the inverse sine of sine? Disappears. I get A. And if I take the inverse sine of this without screwing it up algebraically and making sure I'm in what mode? Degree mode, I should get 67.02. So I know that the three angles over here, A, B, and C, have to add to 180 because it's a triangle. So A is 67.02. B, I don't know yet. C is 31, has to equal 180. I do a little bit of math, and I get 81.98. So now what? Well, now what I can do is I've got 81.98 here. I have side, side with the angle in between, and I can find the area. Let's go ahead and execute that right now. So the area of this triangle will be 1/2 side. What was the other side? 43.17 times the sine of the angle in between, 81.98. I'm going to do some calculation while you do it and see if we all get the same answer. Okay, my calculator is telling me 516.18. Can we confirm? Okay. So the area of this triangle is approximately 516.18 centimeters. Centimeters it is. Centimeters squared. And there you have it. Like, subscribe, be the 100th sub, get GNC gift card, maybe a handwritten workout.